Hello and welcome. In this video, we are discussing graph theory for electrical circuit analysis. Graph theory is used for the electrical network or circuit analysis. Network analysis means what? Finding voltage across or current through all the elements or any particular element of the circuit. We already know different methods for network analysis like nodal analysis, mesh analysis, different theorems, Norton's theorem, Thevenin's theorem, maximum power transfer theorem. All these theorems we can use for the network analysis. Then why we are switching for the graph theory? When your network is complicated and having large number of nodes and mesh or loops, at that time graph theory is preferred for the network analysis. So definition of graph theory is: graph theory is a graphical representation of electric circuit. It is used for analysis complex electric circuit by converting them into the network graph. So what is this network graph? This graph theory is also called as a network topology. This graph theory study the circuit or network based on the geometric pattern of the network and does not make any distinction between different types of the network element, like whether it is resistor, inductor, capacitor, or different voltage source, current source. It study the network from its geometric pattern. Basic elements of graph theory. First element is node. Node is a common point of two or more branches. And second element is branch. Branch is a line segment that connects two nodes, and most important, it represents a single element of a network or circuit. Now, let's study how to draw a graph for given particular network or a circuit. A linear graph is a collection of nodes and branches. So the first step to draw a graph of a network is mark all the nodes in a circuit. Then second step is join these nodes by a line which corresponds to a network element of each branch. Means what? These nodes we are connecting by a line which corresponds to a network elements, means nothing but it is a branch. Now network element can be resistor, inductor, capacitor. All these network element we are not differentiating whether it is resistor, inductor, capacitor. We just connecting the node by a branch which holds any one of these network element. But in case if your network element is voltage or current source, how we can replace it? Voltage source and current source has to be replaced by their internal impedance. So we should know the internal impedance of voltage source and current source. Ideal voltage source, its internal impedance is 0. That's why the voltage source is replaced by short circuit. Whenever your branch holds the voltage source, you have to replace it by short circuit. And internal impedance of ideal current source is infinite. So whenever there is a current source in your circuit, you have to replace it by open circuit. So always we should know the reason why voltage source is replaced by short circuit and current source is replaced by open circuit. These sources are replaced by their internal impedance. And step 3, if in case the direction of current for each branch is not given in your circuit, at that time you can assume any direction of the branch current arbitrary. And if it is given, you can assume whatever the direction given in your circuit. Last step, mark all the numbers for the nodes and branches. Now let's draw the graph. Let's take this is one of the circuit, and for this circuit we want to draw a graph. So what is the first step? First mark the number of nodes. So this is one of the node. This one is also one of the node. This is one of the node. and this node is same. There is no network element here. This is also one of the node. This is also one of the node. So 1, 2, 3, 4 and 5. So let's mark the node 1, 2, 3, 4 and 5. Now we have to connect these nodes by a branch which holds the network element. So first we will draw a line for this branch. Then for this branch, another line segment for this branch, this R1 and V1. This branch holds network element R1 and V1. So we are connecting these nodes. Second, this node and this node by connecting by this branch, and this node and this node. It holds the network element capacitor. You can see here these line segments, we are connecting the nodes by a line segment which holds the network element. We are not checking whether it is resistor, inductor or capacitor or any other element. Then we are connecting this node and this node which holds this R5. Now here this is important. Between this node and this node there are two elements. One is the R6 resistor, so we can connect it by a line segment. But here another element is current source, and we know that current source is replaced by their internal impedance. Internal impedance of current source is infinite. So there is no need to draw a line segment for this branch. So even though between this node and this node there are two branches, one holds the element R6, another holds the element current source. But we are representing only R6 by a line segment, and current source, there is no need to draw a line segment because current source we are replacing by open circuit. Now instead of current source, if there is a voltage source will be there. What you can do? One line segment for R6 and another line segment you have to make here for the voltage source, because voltage source are replaced by their internal impedance, and which is 0. So voltage source we are replacing by short circuit. As here it is current source we are replacing by open circuit. That's why we are making line segment only for the one branch R6. Now next step is mark or number all the nodes and branches. So this is numbering for node 1, 2, 3, 4 and 5. Okay, this should be 5. Now numbering for branches. This branch number we are making the bracket to differentiate node number and branch number. So this is first branch, second branch, third branch, fourth branch, fifth branch, sixth and 7. Now once you number all the nodes and branches, next is, this is just graph. We always need directed graph, means we should know the flow of the current direction. Now in this circuit, flow of the current direction is not given for branches. So you can assume any particular direction according to your assumption. So for this branch 1, I am considering this. In this branch 1, current flows in this direction from node 1 to node 2. Like this, from branch 2, from node 3 to node 2. This is according to our assumption. It is not fixed. Even numbering of the branches and nodes is also not fixed. It depends upon you. Yes, but number of nodes and number of branches are fixed for any particular network. Like this, you have to make the direction of the current in particular line segment or for particular branch, and this graph is known as a directed graph. So here this is the procedure to draw a graph of a network. First step, always mark the nodes, then connect the nodes by the line segment which holds the network element. It can be capacitor. Another, If your branch holds current source, you have to replace it by open circuit, means there is no need to draw a line segment. If your branch holds voltage source, you have to replace it by short circuit. Why? Internal impedance of voltage source is 0 and internal impedance of current source is infinite. So short circuit means voltage source short circuit means you have to draw the line segment. For current source open circuit means there is no need to draw a line segment. So this is a simple technique to draw a graph of a network. Thank you.